Okay, for number 3, we have a histogram. All right, so let's begin. The time taken to route course with 2,500 students is summarized below. So what do we need, guys? We basically need to form a table based on this. Do you want a better shape? Right. Happy. Okay. So we need the class width and the frequency density. Okay. So class width is basically you need to look at if you look at the classes first if they're continuous. They are. So it's just the upper bound minus the lower bound. 20 minus 0 is 20. 30 minus 20 is 10. 40 minus 30 is 10 and so on. 60 minus 40 is 20. 90 minus 60 is 30. Okay. So what about the frequency density? Frequency density is basically frequency by class width. Okay. So the frequency for the first one is 440 divided by 20, right? So like this, you have to continue like this. 440 by 20. That's 22. So if you do that for the others, like 720 by 10 is 72. You guys know it. So we get this 9215 followed by 4. Okay, great. So now we have to give the scaling. So proper scaling should be like this. Uh, we have a maximum value. Frequency density goes on the y-axis. Okay, and the class will go on the x-axis. So we have a maximum value of 92. Okay, so you can go for like one small box is equal to 10. That should work. So this is your frequency density, and below is the time taken. What was the unit? Minutes. Okay, so let's go. Okay, so the scaling, right? 20, 40, 60, 80, 100. This looks good. What about the x-axis? Still 90, right? The same thing should work. 20, 30, sorry, 20, 40, 60, 80, 100. That's great. Okay, so the first class, 0 to 20 is 22. So this is basically 30. So 22, each small box is 2 units, right? So 22, 0 to 20 is 22. This is the first one. Followed by 20 to 30 is 72. 20 to 30 is 72. This is 30. This is 70, right? So 72 is here. You can draw this with your scale. It's going to be easier for you guys. 20 to 30, right? It's like this. Okay. Next, 30 to 40 is 92. 30 to 40 is 92. This is 90. So 92 is over here. Next, 40 to 60 is 15. Okay, so this is 10. 15 should be in the midpoint over here. So 40 to 60 is 15. Like this. You have your scale, it's going to be easier for you guys. And 60 to 90 is 4. So that's just 2 boxes. 60 to 90 is 4, like this, okay? There you go. This is what it should look like, and the answer is also in the mark scheme. They've provided it, so that's good for you guys. So don't forget to label the axis, and you need proper scaling. Okay. From the data, the estimate of the mean value is 31.44. Calculate an estimate of the standard deviation. Okay, how many questions do you have in total? Okay, 6. Let's continue. Calculate an estimate of the standard deviation. Okay, so what do we need for the standard deviation? Firstly, we need the midpoints, okay, of the classes, since it's an estimate. So it's basically the midpoint is like this: lower bound plus upper bound by 2, which is 10, right? So this is 10, okay? This is 20 plus 30 by 2, 25, 35, 50, and what is this exactly? 60 plus 90, 75, I guess, right? 60 plus 90 by 2, 75, yeah. These are our midpoints, okay? Now you guys need to understand something. What is the formula for standard deviation? It's basically root over variance, right? And what is the formula for variance? Variance is basically the summation of x square f divided by n minus the mean whole square, which we have. So it's a summation of x square f, where f is the frequency, and for a histogram or a cumulative frequency graph, the value of x is basically the midpoint that I've written here. It's basically the midpoints, okay? So let's see. So let's begin. So x square f, that's basically 100. You gotta show it to them though. So it's basically 10 square times 440. Okay. So yeah, times 440 plus, the next one was 25 square times 720. Next one was 35 square times, what was it again? 920, then 50. Okay. Okay, so 50 square times 300 plus 75 square times 120. So these are the values. Divided by the total frequency was 2500. N is basically the total frequency, okay? Sorry. Minus 31.44 whole square. So it's best if you show all the steps, So that's 44000 plus 450000 plus 1127000 plus 750000 plus what's the last one? 675000. Okay, should match by 2500 minus 31.44 square. Okay. Now what? If you add it up, you get a value of 3046000 by 2500 minus 31.44 square, which gives us a value of 229.9264. Okay. Now we need to find out the ST. So the standard deviation is root over variance. So root over your calculated answer, 229.9264. So the answer to 3 significant figures is 15.2. Okay, that's it. In which class interval does the upper quartile lie? Okay. So Q3. So the total frequency is in fact 2500. Let's write down the cumulative frequency. 440. 440 plus 720 is 1160. Plus 920 is 2080. Plus 300, 2380. Okay, plus 120 is 2500. So the upper quartile is basically 75%, of the cumulative frequency. So 75 by 100 into 2500 is 1875. Okay. So the upper quartile essentially lies or is the 1875th value? So where does that lie? So the one uh, there are 1160 values still 30, and there are 2080 values still 40. So 1875 clearly lies over here, right? 1875 lies here. It is greater than 1160 but less than 2080. So we're gonna go for this class. So we're gonna go for 30 to 40, right? Hopefully that makes sense to you guys. Okay. It was later discovered that the times taken to travel to college by two students were incorrectly recorded. One student's time was recorded as 15 instead of 5, and the other's time was recorded as 65 instead of 75. Without doing any further calculations, state with a reason whether the estimate of the standard deviation in part B would be increased, decreased, or the same. Okay, so one student's time was recorded as 15 instead of 5. Okay, so we recorded it as 15, while the original, the one we did in part B, while the original was 5. Okay, and the other was recorded as 65 instead of 75. Okay, so basically, let's try to understand what happened. If you think about the mean, right? For the mean, if you add these two up, 15 plus 65 plus some other values, what's the value? 15 plus 65 is 80, right? Right? And this is the false one, and the original one should be like 5 plus 75, 5 plus 75 plus other values by 2500, that's still 80 by 2500. So the mean doesn't really change. The mean is still going to be 31.44. Okay, the mean is still going to be 31.44. Since 15 should have been 5, that's 10 less, but 65 should have been 75, that's 10 more. Okay, so the mean doesn't really change. So this part doesn't change. Then what changes? This changes. So summation of f doesn't change. But what happened to x square f? Check this out. So x square f, for this one, 15 was recorded instead of 5. 5 should have been here. 5 should have been here, but 15 is also here in this class. Okay, but here's the thing. When we find out an estimate of the mean, I was viewing this in a wrong, from the wrong perspective actually. Basically, we wrote it as, what did we write it as? We wrote it as 15. Okay, so we wrote it as 15, but it should have been 5, and we wrote it as 65, but it should have been 75. So that doesn't really matter, because even if the 15 was 5, it would still be in this class, and even if 65 was 75, it would still be in this class. But when we found out the mean or the variance, we didn't even use individual values, we just used the mid value. Do you guys understand? So it won't actually change this value or this value either, because they're still in the same class. Like 5 and 15, they're still over here, and 65 and 75, they're still over here. So this value below wouldn't change. 440 would remain as 440, and 120 would remain as 120. So it wouldn't ultimately result in a change in the estimate of the mean or the estimate of the standard deviation. Okay, so we're going to say that it stays the same. Why? Because the data still remains in same classes or same intervals. And what is the consequence? We can say that the frequencies are unchanged. That's that. Okay. When would it change though? For example, if the original value was 5 but we wrote it as 25, okay, then it would be a different issue because it's in another class.